Okay, sorry I'm late. Mic check, you can hear me?
Yeah,
Yes, we can.
hi Nanda, we can hear you. Karibu sana.
Asante. Can hear you too.
Yeah, I think you can just get started.
All right, thanks.
All right, thank you. Good afternoon, everyone.
Good afternoon.
All right, so good afternoon. I'm glad to be back once again for our session. So I wanted to kick off with a bit of housekeeping, but let me just share my screen. Then at the end, I'm going to share my PPTs. Once I'm done, I'll do some cleanup, and then I'll share this PPT with you on Friday after the last session. I think I should be ready for distribution. So share window. Okay, let me just try and close all my stuff that I don't need here for now. Okay, so recap, maybe if anyone missed last time, I did my introduction. I said I'm Nanda, I'm an alumni. I think what I just wanted to emphasize that I'm an alumni. We share a common bond that can never be broken, at least with you folks. So we went to the same school, and that's really important. So yeah, so I'm glad to take you through this unit on containerization. I know you're already covering LLMs also, and maybe cybersecurity. Yeah, so hopefully you'll be able to gain much from it. Also, let me see if I can quickly just, these are I forgot. I do have the poll results, so just give me a second to see if I can just get those poll results. Thank you for those that took the poll. That was really helpful for me to be able to gauge your where you are at. So it was good, some good surprises, some things that I could have assumed, and yet I didn't know better. So that was good. Just give me a minute to see if I can load the results here. As I do that, in the meantime, was it Edwin or Edward? Edwin, I think. Edwin, I'm sorry. I forgot to take you. I think you put it on chat and I forgot to take the email. Maybe the best thing I could have asked you was just to send me an email. But so just if you can unmute and just did you manage to create the Discord? Or am I getting it wrong? Who had offered to help us with the Discord server? Was it Edward? Edwin? Sorry, I can't hear. Am I? Oh, can you still hear me?
Yes, we can hear you.
Yes, we can.
Okay. Can someone remind me who had offered to help us with the Discord server?
It's Edwin, but I don't think he has joined yet.
Oh, okay. Did he manage to create? But the fact that you don't know, most likely he hasn't. So we'll just do it quickly because I don't think it's going to take us long. So that we can just do it quickly because I thought that we can do it as part of the housekeeping. I'd like someone to help me with the timekeeping. For me to know how I'm pacing the time, I would like for us to take a break at half the time. I think this session takes just a minute. We're supposed to end at 9 p.m. Just kidding. What was the time? The end time was 5:30. So is it like 90 minutes or 115 minutes? So we can do this. Let's do this housekeeping and be done by 4, and then we kick off with the content. And I would like someone who can offer to be maybe the class rep. Could you help me with timekeeping to just let me know when we are halfway, when we are at 4:45. You can take a quick 5-minute break and come back and close up. Is that okay?
Yes, that's okay.
All right, thanks. So after this was good, pleasant surprise to hear that most of you have heard of Docker. Just a few that haven't heard, which is still okay. You'll get to know it today. And then Containerd also, this was also a pleasant surprise. It was half. Then usage was really good to hear that some of you have already used it at beginner level, at intermediate. So at least what is this? Almost more than half have 60% have. Actually, more than just about 60% have used Docker, so which is good. So those who haven't used today, you'll use it. And then lastly, I wanted to know the operating systems you're using, and ended up that most of you are on Windows. It's okay. So, when you're undergrad, we used to really pick on Windows. I didn't know that life has got its own humor. So I'm working on Windows on the daily. But we really used to love Linux, but yeah, either of those is really great. But knowing both, again, it's even much better because you'll be able to use it anywhere. Yeah, so yeah, some of you are rich. You have Mac in undergrad. That is really good. So yeah, that was one of the things. So quickly, I just want to see whether we can fix the Discord stuff right now. So could anyone just get hold of is it Edwin, right? If you could just try to call Edwin and just find out whether, so we don't create a duplicate server. If he hadn't created it, we can just create it quickly. If he has created it, he can invite me. Just give me a minute. Let me see if I can be able to log in here, and then I can. Oh, I created. Oh, this is Edwin. Then we can join. Okay, sir. Let me do that real quick. So in the meantime, I remember that there are questions that I deferred to this week. I've just somehow, I was rushing to my meeting room. I forgot the notebook that I had written the questions on. But I think one person had asked about Kubernetes stuff. So could you just refresh the question and just put it on the chat again? Right now, I'm observing the chat window. So just remind me the questions that I deferred. I said, okay, don't worry, I'll cover it in this session. Just remind me again as I set up this. And any other question that has emerged maybe since our last conversation. Yeah, so as I do that, I'll just put that. Yeah, and also once I've invited you, I would like it to be used. Maybe later on you can still maintain it for the other guys coming after you. So I don't know them, so that you could try and add a few second and third years to the Discord too, so that there can be some continuity even after you guys leave. I know this should be a second. Is it the second last? Are you doing 4.19 right now? Is it 4.1 or 4.2?
4.1.
4.1. Okay. Yeah. So it would be nice to at least have some continuity with this. Oh, you already created. I've created Discord members can join using. Okay, good enough. Thanks. You will actually help me because I was trying to reset my Discord password, so that's good. So can we please join that Discord? That's what we'll be using for any communication, like especially for the project and discussions. If you have any more questions around the project, because I think my last session will be on Friday. Okay. That's good. Mine was trying to update, so I think by the time we are done with the first part, I should be able to do a check and see how many people have joined the Discord. So if you don't have Discord already, I think you see some guides to do that, but I don't think it should be a very complex thing to join Discord. All right. So today the plan is just to remind you what we had agreed last time is that I'll do 2 sessions, 2 more sessions rather, like this included. Introduction to containers, I'll cover it today. We canceled the Wednesday session, and I'll be doing container internals on Friday, and then also give you do a briefing for the capstone projects on Friday at 11. I think we're doing at 11:45. 11:15 a.m. So, all right. So with that, I wanted us just to give you a quick outline of how I'm looking at this, how to cover these concepts for you. So I want you to be the main purpose of this was not to be really theory heavy, because while we are bringing us from industry to come and teach you, this is so that we can bring the practical aspect of it. So I wouldn't want to bore you down with theory. Though theory is really important, you can go and read like further reading, and I'll be giving you more material on further reading, which if you're really interested in this, you can be able to read further. So this is what I'll be covering. I'll cover what is a container, because that question came up, and that is like part of the plan. And also, before I cover what a container is, I'll cover some background on leading up to now containers, like what is an OS and the process, what is a process as part of the OS. And also I can break out and show you a little bit from the computer, whether you're on Mac or on Windows. I should be able to show you like both of them, how a process, like you can visualize a process. And history of virtualization. This one I intentionally skipped it. I don't know why I had put it there, but I intentionally skipped it because I want to again be theory heavy, just talk about stories. I wanted at least we just go to the practicals. So also I'm assuming that all of you have are using your dev machine. So at some point we'll break out to install these things, because they don't take long to install Docker. Mainly Docker, that's what you're going to install today. If you don't have it, you install it, and then especially during that break at the top, then we'll come back to look into hands-on with Docker, just playing around with Docker, seeing how you can create get an image, how to execute, how to pull an image, and also a little bit of container registry. And all these things, we'll be looking at them from the user side, like dev user side. And then next, on Friday, we will flip the coin to look into the internals on what is really happening under the hood when we do these things. And then you can connect with your computer science knowledge. If you remember your operating systems course, I think you did in 3rd year, maybe. Let me see how many people have been paying attention. When did you do the operating systems course?
2nd year.
2.1.
2.1. Wow, even that was too early. That's nice, which is very, very nice. Okay, good. So that's nice. That's nice. And then for further reading, I would like you to, someone asked about Kubernetes. I'd like you to go read on that. That is what you call container orchestration. Let me see if I can pick. This container orchestration stuff, how data persistence, all this. The good thing with these things, they're not really complex. They're all about just commands. But for you as a computer scientist, being able to understand what is really happening under the hood is important for you. So the internals of it, the container life cycle, the container security best practices. So these I thought there was no point to cover them here, but just good to be aware about them, especially Kubernetes, because that's what I previously intended to cover, but I thought it would be too much of an abstraction than just covering the main thing that makes Kubernetes work, which is containers. Yeah, so that's where I'm coming from. And by the way, so feel free to stop me at any point if you have any question. I've been saying that I'll be looking at to see any raised hands, but actually I've not been looking at them, but I've seen one raised hand. So I'll try and keep looking more often. So someone raised, this is Edwin. Go ahead. Oh, that's the time you created the Discord server. Okay, it's put down the hand. I think that's the time he was creating the Discord server. That's okay. Okay, so the concepts I'm going to cover, before I cover what a container is, we need to understand what an operating system is. Maybe I should have put it like this way. Any takers to just tell me what an operating system is, just in your own words, not the textbook definition.
I can say something.
Yeah, go ahead, sure.
So I feel what is on top of assembly, like what someone uses that will communicate to the assembly, that will communicate to the hardware.
On top of us, that was interesting. That's actually a good check. And actually, I can give it to you that way, but though not fully. Okay, I can give it to you. So on top of the hardware, right? But the assembly still also could be still part of the OS. That's good. Who else?
If I could say something, for me, an OS, I'll put it as a resource, a computational resource manager that runs on top of the hardware. Yeah, basically that.
Yes, that's correct. So both of you are correct. I think we can take those two definitions. Yes, as resource manager, but there's another way we can look at it. When you say you're running on top of the hardware, another way you can say is it virtualizes the hardware. So what it does is like it makes the hardware be more like you don't see the processor, you don't see the hard disk, but with your own eyes, like whenever you're using computer or when you're thinking about programming or you're doing anything with the operating system, but you know that the hardware is virtualized, right? You can see it as either as an icon there or it's a particular path if it's Linux. So that's virtualization. So that's just another way of saying it's running on top of the hardware, but it's actually virtualizing the hardware and making all these applications, they look at the hardware. So maybe under the kernel, so I took this a Unix model. So like at the core here, where this red dot is, then take it as the hardware. So the hardware then wrapped around it is the kernel. So what is happening is that this kernel is making, which is part of the operating system, is virtualizing this hardware. So these applications, when they're talking to the hard disk, they think that they're the only ones talking to the hard disk, or they're the only ones using the processor. It makes it easy to program. Like when you're thinking about RAM, for example, like the main memory, it's virtualized in a way that you think you're the only one using that main memory. Okay, so that is like what we can say is what an OS is, and sometimes you can refer to it as a virtual machine. And yes, as someone else said, it is also a resource manager because it's managing, and the resource here is this hardware, which is the scarce resource that has to be used by this like myriad of applications up here, plus the kernel, plus everyone else. So if I go into details of this, I'll be now talking about the OS course, but if you want just a recap, is that, for example, the Unix, I think I've covered it here. The Unix architecture is it's made in what we call a monolithic operating system, where it's one kernel, one monolithic kernel, and now the kernel is one unit. That's it's called monolithic. It's not a micro the other one is called a micro kernel. So with a monolithic kernel, you have the kernel. Wrapped around is the system call. So whenever you want to talk to the kernel, you go through system calls. So for example, when you're opening a file in Unix, so Unix here is covering, when I say Unix, I talk about Linux and all its variants, and also Mac OS is still under Unix, and even Android, plus even iOS also. All these are using the Unix kernels. So with the Unix, you talk to the kernel through system calls that just integers that are mapped to a table that shows like, okay, if I want to open a file, I call this routine, which is actually at the end of the day will be a series of assembly code. Yeah. So that is like how you talk to the kernel. So you can talk directly to the kernel through system calls. The shell also, the shell has things like when you're doing ls, you're listing files, anything here, you're talking through the system calls, and then there are libraries here. So Unix is a very beautiful architecture of like an onion, so layers by layers, so a very simplified and nice architecture. And then also this architecture is really important. So I'm geeking out on open systems, but it's really important in this place from here. Right after system calls going up, it's called user space or userland. And then down here is called kernel space. So kernel space, and this is the transition between, this is the API that is translating kernel space to user space. So Unix, and especially Linux, they've made it in a way that they never break any backward compatibility for user space. So if a user space used to call this system call like open to open a file, and they change even the mechanisms of how the file is opened. The user this is opaque to the user. The user does not know that this changed. So it's an API. That's the purpose of an API. It's like an abstraction you create on top of something to make sure that whenever you change the internals, the outsiders never know about it. Yeah. And then the Windows architecture is a bit of what we call a microkernel. It has units, not really like an onion for Unix, but it has also kernel space, or what we call kernel mode, and then the user space. So user space will have these things like whatever the windows that you see, windowing, even when I'm moving this mouse this way, this is all this being done on the user space, but it's going from the user space and talking to this driver called GDI driver for devices, for graphics, things like scheduling. It's done in executive device drivers, hardware abstraction layer. This is now where someone mentioned I think what was this must have been on Monday. You then said about the assembly. So HAL, most of this HAL is done in assembly language. Even for Linux, it has also a sort of a HAL, an abstraction layer that just the transition right before the kernel to the hardware, you go through the assembly, and the assembly still is part of the OS. Yeah, so that is the OS for you. And now why this is important is because this OS, the unit of transaction, whenever you're running applications, is you run them through what we call a process, right? And we're going to, I'll show you in practice, like I know some of you already have, you know how, like, sometimes when your computer is slow, you can go and kill a process that is taking much of the memory and stuff like that. So a process is just that instance of, whenever you run an application, that instance is what we call what a process is. So let's just do, I think up to this point, the rest is gonna just be practical. So I'll start from yes, okay, I'll start from, I think I can come back to this part later on. Yeah, I can come back to this part later on. But let me start with the process, and then I can talk about the container. But before I talk about, before I show you, let me just explain the theory part, and then we can cover it in the practice. So a container now is that process that when you take it and when you isolate it, it's called isolation. And we'll see it in practice, like what does isolation mean? So it basically creates a virtualization again for that process, so that the process thinks it's the only one running on the operating system. So if you think about that, OS virtualizes the hardware, containers virtualize the operating system. So this is a virtualization on top of virtualization. So a container is a lightweight, standalone, executable software package. Like, you take this as one unit, and on its own, it can run on its own without interfering with the others. And let's take a look at what we mean with that. So I'll just open. Let me just open my VM here. Maybe up to there, any questions?
I have a question.
Yes.
Could you expound more on the meaning of an isolated process?
Good. Yeah, I think I can show you like in practice here. So like what do we mean by isolation? Yes. Yeah, that's a good question. And that's the essence of the containers, that isolation that we create, so that, and maybe I didn't mention also the motivation why these containers came about is because sometimes you create an application and it only runs on Windows, let's say 11, okay? Or it runs on Linux, Ubuntu, let's say Ubuntu 20.4. And then whenever then 24 comes about, and then the app is breaking on 24. But with container is that you isolate that process so that it does not matter whenever you change the OS, it does not really matter. The same way the operating system virtualizes the hardware, so that whenever you change your mouse, whether you're using Logitech or you're using Lenovo, whatever mouse it is, HP, the mouse is just the mouse. The way it controls the graphics or this mouse icon is just the same across. And even when you're using the mouse here, I can tell you my mouse is here, but actually my mouse is on the table. My actual mouse is on the table, but we can just even in our language, you just say, "Oh, move your mouse to the right," but actually my mouse is on top of my table right now. And then it does not really matter even whether the mouse has to look like a mouse, like the old school mouse. It can be even, I'm using, like right now here, I'm using the trackpad. That I'm moving like this, I'm using my laptop's trackpad. Here, I'm using my mouse also here. So you see that virtualization, that everything is the same, does not really matter the actual thing that is being virtualized. So the same thing with that isolating of a process. It makes the process to treat the OS the same way, so that whenever you move from one OS to another, the experience is the same. So, but let's look at it in action. So let me just close this, and I think it's been some time before I ran this. Okay, so I'll be doing both Linux and Windows. So just to cover for both folks. So on Windows, I'll just do it from my Windows. This is my Windows machine. It's actually a VM. So I can do, let me see if I have my Docker running. Yeah, so my Docker is running. Docker images, you can see all the images, but don't worry about all that. We'll get to that later on. But before we get to the container, let's talk about a process. So if you are on Windows, there's this thing called Task Manager. Task Manager, if you can look at it like this way, but you as a bit of savvy people, you should go to the details one. where's the details? So at least this one gives you a better view of the processes that are running. You can see like all these. This is my VS Code. So all these are like application running on Windows, and these are running on top of just the operating system. So if I was to draw, let me see. Okay, I like drawing stuff, but let me try and constrain myself from not drawing. But think about it this way. Let's see. Where is my PPT? Think about it this way. All these processes we are looking at, and this is Windows, they're here. They're running in the user space. You can see system service processes, this box here. These are the processes we're looking at right now here. They're running in the user space, right on top of the kernel. That's the way we stacked the hardware, then kernel, and then on top of the kernel, we have the processes. That's a very simplistic view of how to look at this. And then now what virtualization does is you take one process and you isolate it. It's like, look at it, like this is a classroom. You have all of you are like 65 people, right? Students. But I can say I'll create a cubicle inside the classroom and isolate 5 students and put them there. And then they think that they're the only ones in that class. They don't know that there are 65 students in that class. They think that our class is just made up of five students. So that's what isolation does. And then isolation makes it easy now to think about dependencies and also for security, a little bit of the security, but not purely secure. There's a way you can break the security boundaries for some of this, but let's say for a little bit of the security bit. Now let's look at a process, okay? I'm sorry, a contained process, which is a container now, or an isolated process, which is a container. So another thing so the problem is that with Task Manager, it won't show you everything. So you need one other tool. Maybe if you're taking notes, I didn't put that in my notes, but if you're taking notes, you can add this other tool called Process Manager, Proc Explorer. It's a sysinternals tool. I'll send. Let me send the link on the chat. So these are some of the things I might forget to put in the PPT. But sysinternals. Actually, no. Actually, I already had. I have actually a blog post that explains that and even how to install all those. Let me just give you the link to the blog post. You can look at that later on. Just a simple tool that is just, let's say it's Task Manager on steroids. So let's see. So that is the post. You can take a look at it later on, not now. Okay, so you find that this is a bit more fancy, more like detailed. The color codes, they mean several things, but we won't go into that. But the one thing that I want to bring to your attention is something called session ID, which is not on the list here, but which I can add here. So select column and then add a column on session. Where is session? Here, session. Okay, this is what you want to get with Task Manager. So with sessions, if you look at the sessions, there are things running on session 0, and then there are things running on session 2, okay? So I want to quickly, what we'll do here, we will just create, can you do that? Or that would be too much. I wanted to create a simple, maybe actually that would be a good thing to do. So let's just create a simple, let me see, if I do have GCC here. Okay, I don't have GCC. Okay, that we can do on the Linux side. We'll do because we can do the GCC Linux side. But for now, let's run a container. So a container, you'll need to have installed Docker. But This is what I said in the hands-on. We will do it. We're going to redo the Docker bits in the hands-on. But for now, let me just run the commands, and then don't worry, we're going to redo it together with you. So Docker first is you need to have images. So images are like your exe files. And then whenever you run an exe file, is now what you spin off as a container. Now the instance. The exe file is just an image. It's like in OOP terms, it's like a class. And then whenever you run the exe or you run the image, now you create an instance of the class, which is now an object. So an object here is now what you call a container. So I can create my instance out of a small container called NanoServer. So this is the NanoServer that we use most of the times. It's a very minimal image. So I'm sure there's a new one that has come up. So I can even pull, I can say Docker pull this. This is the tag LC 2022. If there are any updates, you see that download. See that they are being downloaded about 116 MB. The other ones is a bigger bit, like half a GB. And now with this, I can now take this. This is my image, and then I want to run. So as I said, when you're running an image, it's like you're creating an instance of a class, which is now an object. So you're creating actually a container, but it's one container, but it has many things, and you will see. So if you are keen, I want you to have a look at this. This Proc Explorer. Where's our Proc Explorer again? It's right here, and look at the session. See the last session was session 2. You'll see a new session come up here. So let's go to Docker, run. I say run interactive, and then I have for Windows, I have to provide something called isolation, because it has 2 different isolations. So I want to use process isolation. The other isolation is called Hyper-V. We won't go into those for now, but for now, just take this. This is an easy this, and then I can say which program I want to run in the as the entry program. So I say I just want to run the CMD, which is just the terminal. Can I just say run? So now you see why I chose this, because it's very fast. The other one, the server core, is a bit slower. So but you see it was very snappy. I just clicked, and then now I'm inside a container. Now look at this. Now this the virtual. Before I go, actually, we talk about the virtualization bit. Let's go to and then the isolation. Let's look at the Proc Explorer once more time, and then you see. Have you seen the 3 appear now? All this is running inside the container. All these processes from Proc ID. Let's look at the process ID, PID 24, 676, 25. All these are running inside the container because of the session ID 3. But now, outside the container, look at my C. If I say ls or dirc, okay? You see, dirc has different things versus when I'm inside the container and say dirc. You see that it just has what? License, users, and Windows. This one has all these things. And this is my C actually. I'm talking about this C here, my drive C. So drive C is even the internal here. Drive C is virtualized. It's isolated. Like inside this container, it has its own drive C. Okay. And there are other ways again of viewing this. If Visual also make everything clearer. So the other tool again is still under this internals tool, which I've detailed in the blog post. There is another tool called WinObj. WinObj. And don't be scared. These are just tools. Don't be scared by the names and all that kind of stuff. They're just tools that they help you just to visualize things. I think I put it in some. Let me just see if I can get it. Okay, Explorer. Okay, it's right here. So WinObj is down there at WinObj 64. And now you see, so WinObj, it's also another one to visualize this. So WinObj has something we call silos. And that's what a container is called in Windows, in the Windows, our Windows, the way you call Windows. So actually I work in the Windows containers team. So this is now our stuff. So we call our containers, we call them silos. So a silo, just from, you can see the name, silo is, when you say people are working in silos, they're working in isolation, right? It's the same idea. So silos, so if you look at this silo 1804, that's the container actually we created. So I want us to create one other container again, and you'll see which silo it will be in. So just mark 804, right? And then when you come back to the terminal here, let's go to a new tab and create and run another this. So remember we said that image is like a class, and whenever you run, it's like you're creating an object. So you can create many objects from one class. One blueprint creates many objects. So one image can create multiple objects, or sorry, multiple images. So if we go back to WinObj, I wish even I was doing it side by side, you will have seen how you'll see there's a new node that just appears there. But anyways, it's all good. I think you trust me that it doesn't appear immediately, but you have to refresh and you'll see a 312. Even the numbering is not like it has to go serially. Okay, I'm noticing it right now today. I thought it keeps going up, but you see, this was this and this 312. And then you will notice that this will be running in another session. Most likely it will be session number 4. You can see here. Number 4, almost similar, all similar applications. CExec service here, CMD here, CMD here. This is the CMD we said to run. Remember that CMD we said that run whenever you're running, when we did this command here, we said run CMD. This is the CMD that is running. That's the CMD here. Okay. And all these other are Windows services. So far, we haven't run any application of our own. If we want to try like run an application of our own, let's say, which application that can take? I wanted an application that, is it find str? Yeah, you see find this. I'm running find str, right? I'm just finding something that is not there, right? So it's trying to run through many files looking for NA. And we can come back here in the Proc Explorer and look for find str. Can you see find str here? And can you look at this? If I kill this find str, look at what will happen to my terminal. Just say kill process. You see, just stops here. See, it has stopped. So basically, this find str is running in isolation, running inside a silo. Like some Linux calls it a jail. That's how the Linux term used to started off. They started off calling them jails. So you jail these processes into a box so that they can work only in isolation, so that they can be effective and they can reduce side effects. Like one process should not be able to interfere with another one. So it's like whenever you're in a box, let's say someone is making noise, you can't hear the noise from a neighbor. So there's no like that noisy neighbor problem. That's the purpose of the containers. So that's from the Windows side. I don't know if up to that point, if there's any question or anything that wasn't clear. Was I fast? Do I need to repeat something? Because this is actually the basis of everything. If you understand this part now, the rest is just a matter of just commands, which even you can Google, you can do anything, you can find them. But you understanding this concept is important, especially being a computer scientist. Yes. Oh yeah. Okay, that's a good question. So remember that the OS itself has this other process running. Like this is a process running called Explorer, right? It's running somewhere here. If I search Explorer, you'll see Explorer. This is the Explorer that is running. Explorer. See Explorer. It's open here. If I kill it, sorry, oops. And you can see Explorer is running on. Let me minimize this. So this is my Explorer. This Explorer right here. So look at this Explorer, right? And it's running on session 2. So if I kill the Explorer right now, you see it closed. You see it is closed. So the session 2 already is handling the operating system stuff that are happening on what's called the host, not even the container yet. So containers are starting from session 3. And then session 0, no, session 3 or session, let's look at session 1. Session 1, what does it have? So the OS itself has a way of doing this session. There's a session manager service. Actually, this SRSS, let me show you this. There's this service called, what is the host? RMSS. This one, SRSS. This is the process that actually, you can't kill this. If you kill this on the computer, just, it actually won't allow. Let's see. If you try to kill it, you see it won't allow that because it's a very powerful process that manages all these sessions. So the OS decides to which sessions it's running. So various things will run in various sessions, but now these isolations will start from a higher number. But that was a good question. It starts from a higher number, but it will. I don't have an answer of why it chooses to have different sessions for these other services. Like we have zeros in session 1 and the session 2, but just know that this is like its own way of managing the processes that are running on the system. And also, actually, it's a way of virtualization of trying. It's actually a security feature of. Because there are many other things like VTL, things about virtual trust levels. So there's some services that run on a higher like virtual trust level than others. So those will be running on a different session. But then now containers will pick from session 3 going upwards. Any other question before we look at the Linux? For the Linux, people have not forgotten you. We can look into that quickly. Okay, you notice now I did just so you remember when I killed the Explorer, so I think I killed that start. You can see now I've actually messed up my own machine, but what I'll do, I'll see whether I can salvage this. Okay, I can still go with the tabs, but killing Explorer has killed even the shell, but anyway, it's okay. So we can now look at Linux. So I'll pick this VM that I have here, and then I just SSH into the VM. Okay, so this here, I think I do have Docker here on this VM. I better have, okay, good. So the same idea now, but Linux has different images. So if you look at Docker images, Linux has better images, sort of shorter names. If you just want an Ubuntu image, you can just say Ubuntu. So just say Docker pool Ubuntu. Not long. You remember that the tag for Windows was really long. It's something I think was a design mistake that was made there. But so Linux makes things a bit easier. So with an Ubuntu image, I can. So on the host, so this right now I'm on a host. That VM is the host, but I can now make a container, and just to see the difference that if I do PS is similar to that opening of Process Explorer. So PS AUX, it will list all the processes that are on this host. You can see there's so many. Let's count them actually. AUX, and you can pass them through WC, I think. Yeah, that 320 processes that are running. Most of them maybe 319. I think WC just counts all the lines, even the title line. So there are like 319 processes running. Yeah, it also counts the title line. So all these are 319 lines, which are 319 processes, each with its own PID. You can see PID, same idea that you saw with the PID on Windows. So PID idea is the same. So operating systems have similar concepts, but different implementations. So with this, if I do Docker run, the same idea, the same stuff that we're doing, Docker run, this one does not have isolation because this by default isolation is process isolated. So I just say Docker run, and then I want interactive. So and then Ubuntu, and I can say okay, run the shell as the beginning of bash, which is similar to the CMD, and then Docker, there's an R here. It's also very snappy, fast. PS AUX, you see, just only 2 processes. So Linux is okay. First, Linux was the first in the game for containers. So Linux, we didn't go to the history, but the history goes this way, that Linux started container stuff around 2005, I think. Then it picked up in 2008. But Windows came later on in 2016. That's when the Windows started doing containers. So it has been a playing of catch-up game. And actually my team, it deals with trying to bridge that gap between Linux experience and Windows experience. We call ourselves Windows Containers Bridge team. But we work mainly on the open source products to make sure that they're working both on Linux and on Windows. And I don't know if I mentioned that I work on the BuildKit product, which is actually the one that runs, is the bucket for Docker whenever you're doing Docker build, which I think we can cover also later on. Okay, so that's for you. That is now isolation for you on the Linux side. You can see that this one running here, and look at this. The PID is called PID1. And I'll just run some Linux stuff like find also. Like this is the same as find str. So find, let's just say find example and see what. No file collects. Find what. Okay, let me do this. Grep. Let me make it recursive. Find. Something that I know it cannot find. Let's say you Nairobi, right? Nairobi might not be in any of the files here. And you say search from the roots. So okay, good. So I just want to just make it keep running, okay, over and over. Though there's another way we could run the loop. So you can see grep is running here, and grep is most likely PID 3 or thereabout, right? In the container. But so as much as it knows, grep just knows I'm running in an OS that we're only 3 of us in this room, right? But look at the host. If I go to the host, back to the host here. So if I go back to the host and then I do PS AUX, and then I find or I don't want to call grep again because I was trying not to call grep again, but let's say just PS AUX, but look for grep, okay? So look for grep process. I don't want to call grep again because that's the easiest way of looking for grep here. So I don't want to call grep twice, but I can grep with just our eyes here. So okay, we can do grep again. Let's just do for the sake of saving time. Grep for grep, okay? You can see grep is so the last one is the one that I'm running right now because I'm Nanda. Look at Nanda. Nanda is my current user, yeah, Echo user, right? This is what this is the one that I've just run, this grep that I've run. But the grep that it has found that the first hit of grep was the one that is running grep Nairobi. You can remember that we ran this grep Nairobi is PID. Outside there, it's known as PID 1583. No, I'm sorry, this is the PID, sorry. The PID is 3772. but internally, that PID is not internally. How can we check internally? Internally, we can check this PID this way. We could. Okay, anyway, let me not go into details, but yeah, but just one internally, it's given another PID. It's like assuming the same analogy of the class, that you have a big class that has partitions, and every student thinks 5 students think that there are only students in that class. So let's say you are given student ID 1, and maybe another person ID 2, another one ID 3. So they think when you have 5 student IDs, but outside the whole university knows that we have more than 5 students. We actually have 60 students. And actually the actual student ID 1 is another person, not you. It's actually the global student ID 1, but you think you are student ID 1. Also in another box again, there's a student ID 1. Again, another one, there's a student ID 1. Just the way if I kill this here and we look at PSAUX, you'll see that there's PID1, which is always the bash, the one that was the first to start the container, is called the PID1. So this PID1 is 1, but only 1 as far as that container is concerned. But outside the container, this bash is another PID. If you look at outside the container here, if I do this grep for bash, right? You find that bash, the one that's running on root, this one is PID 4588. But internally it thinks it is is PID 1. So actually all these running in root, all these PIDs running in root, all of them are PID 1s. They think they're PID 1s, but they in reality they are different PIDs for the global namespace. Okay. So I don't know if I actually have tried to border around again container internals, because we're actually to cover this in the container internals. I think I've tried to tread in the internals waters, but we'll still cover this on Friday in the container internals to look into the specifics of this. I see one hand raised. Gloria, go ahead.
This is for timekeeping. We're 7 minutes past break time.
Past, oh my, yeah. All right, we can actually, there's a good point to stop, but if you have any questions, you can keep them and then bring them up after break. So can we come back at 4? No, sorry, 5:00. So I'll give you 8 minutes break. All right, see you then. Thanks.
Excuse me, you're muted.
Sorry about that. Wow, I've talked a lot, but anyway, it's okay. Sorry about that. I thought I was okay. First, welcome back. I said if you have any questions, let me know. You can put them on chat. But I wanted to clarify something about the commands. You notice that on Windows, I was using the GUI a lot to explain some of these things, because Windows, by its history, was a GUI first operating system where most of the things are done with the graphical user interface. But for Linux, graphical interface is something you just add on top. Like you can have your operating system running only the shell. So if you go, if you remember that architecture diagram we had, so Windows, the GUI bit works with this. These are the things that they do the Windows. So the Windows system, windowing, OS2, all this. All these are what we call the Win32K sort of subsystem, and then it goes to this GDI device driver. Now what we can see as this UI GDI, this is the GDI graphic something interface. So it's really GUI first, Windows, okay? But Linux, on the other end, it is shell first. So shell here, this is like just with the shell, you can be able, whatever you saw those interactions, we're doing PS AUX, it's actually a PS is a shell command here. It's just like doing a syscalls and then interacting with the kernel. And then the GUI just comes as an application on the top layer. That's where you bring the GUI. If you want a GUI, for example, on Ubuntu, you do that. Like my Ubuntu right now, I'm not using any GUI. I just SSH'd into it through shell again. SSH is called a secure shell, which is still shell, and I get into the operating system. So that is it. So I wanted just to show you something that on Windows, yes, Windows has equivalent of those, but some of them don't come out of the box in the container. So the container does not have task list. Task list is here as a command, it's task list.exe even, but it's not there in there. You can see it's here, but it lists it like the equivalent of PS. grep, for example, whenever we were doing grep, that was like equivalent of find str. Like grep, so I can still pipe it and say find str. So let's say find the VS code or something with the code. Can okay, I have to say find. I think it's star. Anyways, it doesn't work. Just forget about it. It's all right. It's all okay, but you can see that it's you can list tasks, and find str is the equivalent of grep. So all this. So again, you see the container here it has how many? It has like a long list of applications running on the host, but on the container. So if I let me pick now a container that has task list. So compare this task list here, task list on the host, the same as doing that PS AUX. It's a very long list, okay? I don't know the Windows quick command of WC of just trying to list all the number of lines, but for now we can work with that alone. And then maybe measure, but I'm not sure about that. Yeah, 350, 350 or 49, because it's counting also the first line. So 349 lines, okay? Well, process is running. And then if we go now into the container, like we say docker run, so docker run, but this time, because Nano Server does not have task list shipping with it, we can pick a bigger image that's called server core. So I can change it to server core. And this time I can even choose PowerShell, because PowerShell is more powerful. So the PowerShell process to run as the first process. I'm sure it takes a little bit longer than NanoServer, but you see now we are in. If I do task list, you can see, and then I do measure, you'll see that it will have a smaller list. See, 26 processes only running. Can you see that? So it's the same idea that we did with this PSAUX outside here, PSAUX. I think it was, which is WC, it was just word count. WC stands for word count, 325 processes. Okay, coincidentally, all of them are in the 300s. Interesting. It's just coincidence. And then the other one is 350. But now when I get into the container, look at, so that's why the Windows, the Linux containers are much more lightweight than the Windows counterparts. So Windows container, look at AUX, PAUX just gives you only 2 processes, you see? And even, actually it's only 1 process actually, sorry about that. This PS is actually the one that is a recursion. So the PS that I've run here is actually what is PID 12, which only runs, and by the time it gives you these results, it has already exited. So the only running process is PID 1. So you can see Windows has 26 processes running. Linux has only 1 process running in a container. So it's a historical thing. Windows, like was trying, has some other baggage it has to deal with for it to be able to run containers efficiently. But Linux, from the get-go, it had this container idea in it. Actually, it was actually an old idea, but only discovered in the 2005 thereabouts, and now repurposed into these things like Docker and all these others. Okay, let me pick some questions. If you have any more questions, you can raise your hand or put on the chat. What's the purpose of the loading WSL together with Docker? So, good question. WSL is another. WSL, how do I explain to you WSL? And even most likely in the if these just a minute. Okay, this is not up to date, but up to date one. So WSL was actually a spin-off from this OS/2. So WSL will fall under this sort of subsystem here. Maybe it can be put here as a WSL, another box here. That's where the WSL falls under. So WSL is just an option, is another way of Windows was built with this extensibility so that it can work with POSIX. So POSIX is a standard that came up with from the Unix side to make sure that all Unix systems and its descendants have similar interfaces on how they do commands and all that. So we're using this POSIX idea. Windows had this subsystem for POSIX, which it extended to make it WSL to allow Linux to run inside Windows. So if, luckily I do have actually WSL here on my computer that I can show you. So if this is my terminal, this is now the current computer I'm running on, not this VM that I was showing you. So I have, sorry, just mistake that. Okay, so if just say WSL, I get into a WSL. Again, this is also part of virtualization because now I get into an OS, but still running inside another operating system, which is sort of a VM of sorts, like a nano VM. So it's now spinning it up because it has to start the processes and all that. So we'll give it a few minutes and it will start. But back to your main question was, the purpose of downloading WSL together with Docker is to be able to now run Docker for, so there are two types of Docker, the Docker for Linux and Docker for Windows. So with WSL, you can be able to run now Docker for Linux. What we call, so that that's a very good question because that's actually what we deal with actually in my day-to-day work. We deal with that bridging, as I told you, like that bridging of the two. So let me just note it down here, this verses. So we have what you call wowcow. Let's start with that for Windows, in the Windows scenarios. Windows scenarios. We have what you call wowcow, which is my current work. I work on this wowcow stuff. So wowcow just means, it just sounds like fancy, but it just means Windows containers on Windows. And then there's lcow. Now this lcow, this is where WSL comes in. Linux containers on Linux. This is why you need WSL. So here you need WSL for that. Yeah. So, and actually, I'm sorry that I did not. Okay, maybe now in the hands-on. No, that time I was just trying to explain the. Let me remove this note. I was trying to explain to you the. What's it called? The high level of it, but now in the hands-on, maybe I can delve a little bit further into that. Yeah, so I can delve further into that, Felista. But that's a very, very good question and a very good observation. Why we need this. That's how actually a computer scientist should be thinking. You should not just look at things and then you should be asking why. Why is this put here? Why is that like that? So that's a good question. You had said something like processes in Linux are isolated. Does that mean that when you run something like grep, it doesn't know about the other processes like bash that are running? Yes and no. So that it doesn't know about the other processes that are not in that container. That are not in that. So remember when you did grep, I've shown, and maybe even I've answered this question maybe through my explanation so far, but let me just reiterate. So we had, and this similar with Windows, same idea. Processes now here, we only have PID1 running in this container. I'm now here current container, and even look at the user. In the current container, I'm a root user, which is like the most powerful user. On the so if you look at echo user, I'm a root user. Okay, still you can pick it from. Oh, that does not show. Okay, interesting. Okay, this is interesting. It should actually show that I'm a root user, but anyway, whatever this is happening, I don't know, but you can see here is root at. So this is what I'm running on, and then on my home. Sorry, on my host machine, the user here is just Nanda, the current user, right? So and up to your question about the isolation is in the container we only have one process running. This last one, as I said, it was just a short-lived process that ran quickly and it stopped. And even you see if I run another PSUX, look at the PID that will be given. It will be still PSUX, but look at the PID, it will be 13. You can see 13. And most likely you might guess that the next one will be 14. Okay. So it just short-lived. It runs and stops. So the only one that is long-running is PID1. So this one, of course, even bash is the one that is making us to run PSAUX in the first place. Yeah. So these two are like siblings. They're in the same classmates. They're in the same container, but outside we have all the rest. Yeah. I hope that answers. Do you have also daemons running within containers that can be maintained during boot time, managing Docker containers? Okay, so container, okay. That's a good question, but a question that can help clarify everything. So remember, this container is actually a trick. Virtualization is more like a lie, sort of, quote unquote, a lie. So let me see if I can just draw this. So that is Edwin. I want to find the quickest way I can draw without really complicating this. So just give me a minute. Figma. Yeah, it looks like we ran out of time before doing the hands-on, but that's also a good one for you to take it as an assignment. Something like an assignment for you, actually. So the assignment will just be to go through that tutorial that I sent that link, and then we can check in on Friday. Even we can check in on during the week on the Discord server, see how many are stuck, or if you have any questions. So, but I think those questions are good. Let me just clarify those questions. Because the rest, the practice, believe you me, it's very easy. Like you can even go check out even online and stuff, and you can just figure it out. So the questions for me are really important to make sure that I clarify this part, and then if I can make it a bit easier. Sometimes they'll come. It comes also sometimes with time that you that visualization just now clicks. But I hope that this one will be a good step towards the right direction. Just give me a minute, see if I can get this this whiteboard. And as I do that, any more questions? Because then I'm conscious of time. Looks like I'm only having 12 minutes. I don't want to keep you further. It's already late. I'm sure you had a long day. Maybe even by now, some of you have already switched off. So let's see. Yeah, my whiteboard is taking long to load. I just want to show that that will show you that there are no any demons, or the answer, maybe the short answer is that there are no anything else. There's nothing. It's just those. I don't know. There's only that page. Box laughing. Is there anything on the chat? Let me see. Yeah, this I think my compass, but I don't have many things. I've closed most of the things. I don't know why it's overloaded. It's really taking time to open stuff, but so yeah, so back to the chat. Yeah, so Edwin, yes. So the answer is the short answer is do you have demons running? No. The short answer is no, unless you run it. So everything that's there, you have to run it. And then whether it's a demon or whatever thing that you want to run, is you have to make sure that you are saying run. And a demon basically is just a process running in the background. That's a demon, right? Just running in the background, not on the foreground. And even if it's in the background, doesn't mean that it's hidden. You can be able to PSUX and AUX, and you can see it. So the fact that we did PSUX, and the only thing we've seen is that only PID1. As I said, the PID 14 or 13, those are ephemeral processes that actually the same PSUX process is the one that is taking this ID. So it's like a recursion. So the only main long-running process is this PID1, and that's all. That is it to do with that container. Yeah, so the answer is no. And the container, don't look at the container. So you mentioned about boot. Containers have this idea of boot. For example, the Windows container, we have this idea we call booting, which it emulates almost the same booting process that we do when you are booting the whole VM or the operating system, but it's a little bit different. It's a lightweight kind of booting. It's not the booting that we do, the sequence that we do whenever we are setting a operating system, things like checking for the keyboard, everything, looking at the hardware, like a health check, and then loading the bootloader and stuff like that. So these are a bit different. Just basically just spins off. Just make sure that everything is available the same as the way it's available for the process on the host. So there's not any first class process and second class citizen. All of them are treated similar. So the only thing that is done like boot-like is just preparing the environment similar to what is there on the host. But I wanted to just visualize that aspect of host versus container. But my just my Blackboard has refused to load. But I can do that on Friday. We can do a recap on Friday and show, just visualize that containerization in that aspect. I think that will help really clarify everything. Yeah. So, Tevin, you asked, do my non-ephemeral show? Yeah, I was saying that this PSUX is ephemeral. It just runs, it lists and then stop, and then it's like it just short-lived, just ran for few minutes, and then basically stopped. So that was the why I was calling it ephemeral. Yeah, but this one is running long-lived. This one doesn't stop. If you stop it, if you kill it, then the whole container stops. So the problem is like I'm having so many. So if you look at my PS AUX here, and then I do grep for bash. See, I have my number of bashes. I don't want to kill the wrong bash. I just have so many other bashes here. But if I was sure which bash, well, I could be sure if I just confirm something else here. You can see this is 4588. Most likely, no, sorry, PID 3968 and 768, 512. So if I do a kill, if I kill one of these processes, then the container just stops also immediately. So the entry process, when you kill that entry process, the container stops. So maybe actually a good one is using the Windows one. So the Windows one, I'll go back to this. Good. So look at this. We have we had our last. This is the last session we ran. The Windows. Where's the Windows session that we ran? This is the last one that we ran. This maybe is on session. This could be session 5 or what? If I go down, should be session 5. Yeah, that's the last session. So look, the entry was PowerShell. Remember PowerShell? And now, if I say kill PowerShell, because that was the entry process, it will kill the whole container. Because that was it's the equivalent of PID1. So you see the whole container has been cleaned up. So you saw those red things, that was cleaning up happening. And you can see here everything exited, and I'm back to my host from the shell here. Yeah, so that's it. Paint. What about Paint, Felista?
Oh, I was just saying you use Paint to draw what you wanted to draw, but it's okay. It's fine.
No, you have actually a good point. Because actually this is okay. Thanks. Yeah, because this is just taking me. I don't know why I was not thinking about it. Imagine that now it's still loading. So I could actually close and then just, actually Paint can work. Yeah, that's why we problem solvers. Should not overthink. Paint, let me open. Paint could be faster. Let's see. Yeah, maybe for the remaining 4 minutes, we can do that. Yeah, Paint was successful, so open, good. Take it the other side. Yeah, this is awesome. Thanks for that, Alista. So remember the 350 processes we looked at. So look at them as this is the classroom, right? These are the processes, all the list of processes like the. You guys remember your set theory or whatever? This is the universe, right? And then so all these 350 processes are here, including the 26 that we were seeing inside the container. So yeah, I can tell my computer is just a bit slow now. Yeah, but just think about it that this is the outer, the one that's running on the host. So this is the host. And then on the host, if I open a container, I'll basically, I'm just creating a new, so whenever I do a container, a Docker run, okay? So whenever I do a Docker run, I'm just spinning off a new instance of a number of processes, at least for Windows, about 26 processes that are being spinned off. So the first one, if I open this, now 25. If I open another one, another 25. But remember, it is adding up to the bigger, it's not like 25 being picked in us. So if I started off, if my outer was 350 processes, by the time I open this new one, I'll be going to 375, okay? But they're contained inside this wall, the world here, like siloed. So they're called server silos. So when they're siloed here, when you do task list, you only see your process here. Here also you see your own C. Drive C is, you have your own drive C, which is not the same as the drive C that is on the host. And actually this is what I also wanted to show you some time also back with WinOBJ. So WinOBJ is a very powerful tool for visualizing this stuff. So if you remember this, if I refresh, I'll see even more, because I think we did a number of other processes here. Refresh, so 314. If you look at global, it's global. Yeah, it's global. So drive C is just actually a driver. Drive C, whenever you see drive C, is a driver, that a device driver, and you can see it is virtual hard disk. This, okay. If you are keen and look at these numbers, starting from BB and ending with 7B, okay, and then I go to the global namespace here and look for virtual, again, symbolic DD ending with what was it, DD or BB ending with 7B? Let's go back there again. So here, look at this. It was BB ending with 7B, and then look at this one, BB ending with 7B. It's the same driver. So this is the same drive C. Drive C that is virtualized inside here, inside this 312 silo. You can see this. So that is the when now, whenever you say, this is exactly when you say, there are list for me everything in C versus list for me everything in C here. C at least only 3 things for you. How many things? More than 3, of course, more than 10. So you can see measure, you can see that 25 items here. Maybe except the title. Yeah. So I hope that clarifies. I see we are right on top of our time. So I can, at this point, we can cover up any other thing on Friday when we look at the internals. I'll do some quick recaps. But remember that the assignment is just to go over. That's the link. If I can send the link, maybe the class rep, you can just pick the link once more time. Let me see. Of the practical bits. So maybe I can cover a bit of that also next when we meet on Friday, but that can be a good thing for you guys to do like further reading on. Maybe before I leave, I just wanted to mention BuildKit is the project that I work on myself. Basically, we're trying to bring, right now we have, if you look at BuildKit, I'll send these links on the chat. If you look at BuildKit, we didn't have Windows support on BuildKit. So we picked up this project this year. In March, we did a release for Windows. So if you go to docs, this Billy WR, these are my workmates who work on them on this project together. So if you look at Windows has now the guidelines. Look at this. I've clicked open Windows. Yeah, I'll send this link. You see that the details on how to set up on Windows, build kit and all that. So this is a plus. So if you can go and do the build kit setup too, for if you're on Windows, it's a plus, but you don't have to do that. All I want is just for you to set up Docker. But so build kit is the backend that powers Docker on the building side of the container building side, which you also can cover next on Friday. So this is the what you call the builder. So yeah, so some of the work I've done so far, you can see about 23 PRs. If you want to look at the code, what's it? Just go. If, maybe I should have asked how many of you have already done Go. A good thing for me to know. If you're interested to contribute to this project, let me know. I can see how I can onboard you. If you have some knowledge of Go, so you'll have an easy time. If you don't have, you can still learn. It's not a very hard language, especially if you've already done C. You can be able to figure it out easily. Yeah, so this is what I work on. I have like 2 PRs that are still pending. I just saw someone comment on the PR like this just before I came to the call. We've been having backs and forths on the approach. So I think he was requesting something. You can see here, I haven't gone over it, so I'll go on over it and respond to them. Yeah, so that is it. But if you want to know more about BuildKit, yeah, let me know. I can see how I can help you like on board on the project and try and make some contribution. Actually, this is a best resume is when other than putting like so many things on your resume, just sending a link of things that you've done on a project that people can go in because it's open. They can go look at your code. They can see how you write code. They can see everything about you. So yeah, these are very good. So I'll encourage you to pick up open source projects whenever you can. Don't have just to be this one. Any project that you, especially that you're passionate about. If you're passionate about LLMs, there are many other LLMs like sort of projects you can get online that you could try and contribute to. Yeah, I can end at that point. 5 minutes past time. Maybe I can take it back to Dr. Wanjiku for any like class dismissals.